In this video, we're going to turn our attention back towards Redux 101, and we're going to be using destructuring to refactor and improve the code over here. So to kick things off, step one is going to be to actually run this file over in webpack config. I'm going to change from running destructuring.js to running redux 101.js. We can now save the webpack config file. We can then restart webpack over inside of the terminal, shutting down the old dev server and rerunning it. And the end result should be our output from Redux printing in the console. And that's exactly what we're getting. So at this point, we are once again running the Redux 101 file, and we're going to kick things off by talking about a series of functions that we're going to be creating. And these are categorized as action generators. Action generators are functions that return action objects. So the objects that we're currently creating down below are actually going to get created in just one place, and we'll have a function we can call to generate the action objects. And we'll see why this is going to be useful in just a second when we start creating our very first one. So let's go ahead and do that. We're going to create a single action generator that's going to take care of generating the action objects for all of our increment cases, whether we include increment by or whether we do not. We're not going to worry about reset or decrement or set just yet. We'll handle those a little bit later. So up above, how are we going to get this done? Well, step one is to just create a function, and we're going to be using arrow functions here. A new const. I'm going to call this one increment count, although you could call it anything you like. And I'm going to set this equal to an arrow function. And the goal of an action generator is to be a very simple function that takes input in and returns the new action object. So in this case, for increment count, I would want to, at least at the very core, return an object that has the type correctly set. Right here, I'll set type equal to increment. Now at this point, we can just see our function returns an object, so we can do that implicitly using the shorthand syntax. I'll remove the curly braces. I'll wrap the object in parentheses, which we need when we're implicitly returning objects. Then we're going to go ahead and just set up the object once again. Type equals increment. Perfect. So we have this in place, and it seems to be pretty useless. And for the most part, you are right. We're not getting a ton of advantages just yet, but we can actually go ahead and explore how this can get used. So what we're going to do is take this function and call it instead of manually generating this object. Now let's talk about some of the advantages so far. One of the disadvantages of manually generating your objects every single time is that typos are not easy to catch. So if I accidentally put two T's inside of increment, we're going to see the data isn't changing correctly, but I'm not getting any clear errors saying, hey, that action type is not handled by the function above. But if I tried to use store.dispatch and I call the function we just created, increment count, we are going to get the action object back as expected. Once again, things are working. We go from 5 to 6. The cool thing, though, is that if I mistype something here, we're actually going to get a real error. So over here, we see reference error. Increment count with two T's is not defined. This makes it way easier to avoid typos. And we also get the added benefit of auto-completion of those function names. So we're going to be preferring action generators over inline action objects. That's just one of the reasons. We're going to go ahead and talk about a few more right now. The next thing we're going to do is figure out how we can use our action generators to handle the custom data that we need. So in the case of increment, we have increment by. For decrement, we have decrement by. And for for set, we have count. So we want to go ahead and actually set a lot of that up inside of the action generators. Let's see what that's going to look like. Down below, we're going to comment out this call that increments by 5, and we're going to replace it with another call to store.dispatch. Here, we're going to go ahead and dispatch an object, and that object comes back from calling increment count. Now at this point in time, we have no way to handle increment by, but we are going to actually pass it in. So right here, we are going to pass in as the first and only argument to the increment count action generator an object. On here, we're going to provide all of the custom data we need. In our case, there's just one piece, increment by, and I'm going to go ahead and once again set it equal to 5. Now, if I try to run the program like this, we're not going to get an error, but we're also not going to have the count incremented by 5 because there is no handler for the argument passed in. The action generator contains no code for that, so we go from 0 to 1 and 1 to 2, as opposed from 0 to 5 and 5 to 6. To fix this, we have to actually do something with the argument right here. We're going to go ahead and just kick things off by naming it. I'm going to call it payload. And if payload doesn't exist, we are going to default it to an empty object. So there are times where it's not going to exist, and that's okay. We're just going to use an empty object right here as the default value. Now we can go ahead and actually set up the things we need on the action object, and we're going to be setting up increment by, and we're going to be setting it up for every single instance of this action object, which means that we're going to come up with the default right here as opposed to down below in this function. So right here, we're going to start by checking the type of payload dot increment by. If it is equal to a number, that's fantastic. We'll go ahead and actually use that value right here as the truthy value for the ternary operator, payload dot increment by. If it doesn't exist, that's fine too. We'll just go ahead and default to 1. Now that we have this in place, we no longer need the const down below. We can actually remove that line completely. And right here, we can just access increment by off of action, knowing that it's always going to be set, and it's always going to be set correctly, either to the thing that was passed in or to 1. Now, if we go ahead and save the program, what's going to happen? Well, we're going to see that the count is now fixed. We go from 0 to 5 and from 5 to 6. Some people aren't quite clear why we need the default here. If I were to remove the default, and I had situations where I didn't pass anything into increment count like I do right here, we would be trying to access a property on an object, and that object is actually undefined. And accessing a property on undefined will throw an error. So if I save the file, we are going to get an error. Cannot read property increment by of undefined. To fix that, we're just going to use the default object, which we already set up. So now we have a pretty good system in place, but what I would like to do is use destructuring to take it one step further. It's important to note that when we are destructuring, we can destructure either like we saw before, when we just have an object and we destructure right here as a full line, but we can actually also destructure arguments that get passed into functions. So to mess around with this, let's say we have an add function, console.log, add, and instead of having 2 arguments like 1 and 12, let's say we have an object, and on that object we have 2 things, like the a value, 1, and the b value, 12. Now, how could we set up add? Well, we would just create a const, add, setting it equal to an arrow function. Right here, we can access the object. We'll call this data, and we can return data.a plus data.b. Nothing earth-shattering here. We go ahead and save it, and everything works as expected. We get 13 printing to the screen, which is indeed correct. If we want to destructure this object, though, we can. So what we can do is just remove the name and use curly braces instead. So right here, we are destructuring the first argument that gets passed into add. In this case, we know that's going to be an object, so it's perfectly valid to set this up. We can then use destructuring exactly like we did before. So I could go ahead and pull off A and B from that object. I can then reference A right here and B right here without needing to be able to access the data object itself. And the end result is exactly the same. We get 13. Now, if I did pass another argument in, we would just set that up right here. Let's say I pass in C as a separate argument entirely. Over here, I can pass in a C value of 100, and then I'll add that into the equation as well. So when we are destructuring, we can destructure just one of the arguments as long as that one is either an object or an array. Now, the cool thing about this is we can set up default values as well. So let's go ahead and start messing around with this in increment count. I'm going to remove that code, and we're going to kick things off by just taking payload and replacing it with an object, which is what we had before. So at this point, we are not destructuring anything. What we do want to do is destructure increment by. This is going to give us access to the increment by value off of that first object, which means that we can just access it directly. We no longer have payload. Now, this is great, but we can take it one step further. When we destructure, we know we can set up default values. So I could actually say, hey, if increment by exists, great. If not, use 1. Now we can vastly simplify the code down below. Instead of using an operator like this, all we need to do right here is reference the variable increment by. And we already know that when we are setting an object property equal to a variable name with the same name, we can actually simplify it, like this. And now we have a much nicer setup. So this is going to get the exact same job done. We are going to use 1 by default, and we'll use the increment by value if it's actually passed in. So how does this actually ever get set? Well, it's going to get set equal to 1 if there's an object provided and it doesn't include this. If there is no object provided, the default is going to be an empty object. And when we try to destructure that empty object, we're definitely not going to have increment by. So the end result, once again, is 1. Now this is just for one of our action generators. Increment count is now working as expected. Let's go ahead and knock something out for the other ones. We'll do one more of these together, and then I'm going to require you to do 2 on your own right here. We're going to go ahead and set the action generator up for decrement. So I'll create a const. I'll call this one decrement count, and we're going to set it up exactly like we had before. It is an arrow function. We will implicitly return an object, and at its very core, all we need to do is set type equal to decrement. Now we can actually start taking advantage of this down below. In our simple cases, we can set things up. So I can remove the object right here, and I can call the function instead, decrement count, calling it with no arguments because we don't need to provide any. This is going to decrement by the default, which is 1. Now we can do the exact same thing for this one, even though it won't work right away. So I'm going to remove the inline object, and I will call decrement count, passing in some actual data as that first argument. We are going to set decrement by equal to, and we'll go ahead and decrement by 10. Now that we have the calls correctly set up, let's go ahead and actually add the logic. If I save the program right now, we always just go down by 1. So we go from 0 to -1, and then we go from -1 to -2. In reality, we should be going from -1 to -11 because we told it to decrement by 10. To handle that up above, the first thing we're going to do is destructure the argument that gets passed in. If it doesn't exist, we will start it off as an empty object. Now, what do we want to grab off of that thing? Well, we want to grab decrement by, and if it doesn't exist, that's fine. We'll go ahead and default it to 1. Now we can actually toss that right on the object. Right here, I will set up decrement by, setting it equal to the variable with the exact same name, and this is going to allow us to actually remove the const inside of this function. We can remove the const and we can just access decrement by right off of the action object. It's always going to exist. We set up the default up above. Now, if I go ahead and save Redux 101 over inside of the browser, we are going to see the correct result print. Over here, you can see we are getting the data as expected. We go from 0 to -1 and from -1 to -11. So everything is working really, really well. We now have 2 of our 4 action generators in place. It is going to be your challenge to create the other 2. You're going to be creating one for set and one for reset. So right here, you'll have something like set count, and then down below, you will have reset count. Now, what I'd like you to do is set up both of those functions up above, and then down below, you're going to replace the reset object and the set object with actual function calls. So you're going to be calling the action generators that you set up. Take as much time as you need to get this one done, and when you're done, test your work. Make sure the changes to the Redux store are exactly like they currently are. Both set and reset should still be working. Take a moment, pause the video, test your work, and when you're done, click play. All right, let's go ahead and knock these ones out. I'm going to start with reset right here. I'll make a const called reset count. This is going to be an arrow function, and I will implicitly return an object. On here, we want to set a type equal to reset. Now, the great thing about reset is that there is no way to ever pass data in. It just always sets it equal to 0. So we don't need to add anything onto this action generator. It is complete. Down below, we can now use it. I'm going to get rid of this object and replace it with a call to reset count. Excellent. Now, the last thing to do is just tweak set. So up above, we are going to need to create a brand new action generator for that. A const set count. Set count, once again, always going to be an arrow function, always going to implicitly return an object, and we are always going to provide the type. The type for this one is set. Now set does indeed take some data, and we know that data is required. You have to pass in the value you want to set. We never had a ternary operator to conditionally check that. So down below, we can set it up a little bit like this. I will call set count. I will pass in my data as an object, the very first and only argument, and I will set count equal to whatever I want. Now I had set it equal to 101. So right here, 101. Now that we have this in place, we can go ahead and actually handle the object up above. Right here, we are going to get the payload. We can just use destructuring to get the count. There is no need for default values because we've required it for set count. So we're going to force the user to provide that stuff. Then down below, we'll just toss it on count. If I go ahead and save the file this time around, we should still see things working. We are indeed getting reset to 0, and the count is getting set to 101. If I were to change that information, like changing the count over to -100, we should see that showing up as the final change, and it is indeed showing up. So now that we have action generators, we can vastly simplify the thing we do a lot and make slightly more complex something we only need to do one time. Previously, we had to define those objects over and over and over again. Instead, we just do it one time, allowing us to make simple function calls throughout our program. Later on in the course, these action generator functions will get broken out into their own file. The goal for now, though, is to just be able to see everything that makes up a successful Redux application in one file. That makes it a whole lot easier to reason about exactly what goes into using the tool. Now that we have a very simple Redux example in place, we're going to go ahead and build up the actual Redux functions and actions that are going to make up our application. I am very excited to get to that, so stay tuned. I'll see you in the next one.